Hello, welcome again to this channel. Today we are to solve this equation, the electromotive force and current waves of a circuit having inductance only. Pure inductance are we have here the voltage as 101.4 sine 2 pi 25t, and for the current is negative 17 cosine 2 pi 25t. So we are to determine A, B, C, D, E, F. Okay, so let us have the solution. Okay, for the solution, so to this problem, let us first solve for letter A, and letter A is we are to get the equation of the power. So the equation of the power wave again, but since given here are the voltage and the current equations, we can apply the concept that power is equals to the voltage times the current. Okay, so the voltage is 141.4 sine. Okay, this is 2 times pi times 25t. This is for the voltage, and multiplied it for the current, which is given also negative 17.0, and equation is cosine 17.0 negative cosine 2 pi again times 25t. Okay, so we right away multiply the terms outside the trigonometric value, which is the sine and cosine. That is okay, 141.4 times 17 or negative 17. Okay, and give us 2403.8. Okay, but since that is positive and negative, it will give us negative, so that is 2403.8. okay, so I just copy this one, sine 2 pi 25t sine, and then cosine 2 pi 25t. Okay, now we are going to apply here the trigonometric identity that sine 2a is equals to 2 sine A cosine A. Okay, so this is the trigonometric identity that we are going to use. Okay, now in this case we have here our A here will be equal to 2 times pi 25t. Okay, so therefore that is the case, so I am copying it 2403.8. okay, and I have to extract one here, which is 2 over 2. So that will be sine I am copying it. 2 pi 25t. Again, copy cosine 2 pi 25t. Okay. So this one, this part is this value. Okay. So therefore, that will be negative 2403.8 over 2, and I will now be using sine 2 and a, which is 2 pi 25t. Okay, so therefore we can have it multiplied, this one, so that is 2 times 2 times pi times 25. It will give us 314. So that will be negative 2403.8 divided by 2 sine 314.16 t. Okay, so therefore the equation of power wave is 2403.8 divided by 2, which will give us 1000, negative 1020.9. Okay. Sine 314.16 t. Okay, so this will be the power wave equation for letter A. Now let's proceed and solve letter B, the frequency of the power. Okay. So since that here our A is actually our omega, so yung omega natin is actually, this is okay, instead of having an equal sign, let us use an arrow, and omega is 2 pi f, okay, for the inductor. So therefore our f can be manipulated from this formula, which is omega over 2 over pi. Okay. But here we have 314 as our omega, so 314.16 divided by 2 pi, and we use the calculator. 314.16 divided by okay, so pi times 2, or 2 pi, okay, equals 50.0001 or 50. This will be the frequency. This is 50 cycle actually per second, or hertz. Okay, so this will be your answer for letter B. Okay. Now let's have letter C. We are solving for the maximum value of power wave, so maximum value. But since here in our equation, for the equation of the power wave, okay, the maximum value is we have here negative 1200.1 as the maximum value of the power, multiplied by the trigonometric function sine 314.16t. So therefore the maximum value is actually 1201.9. okay, so this will be the maximum value The unit is watts. Okay, the maximum value of our power wave. Okay, just put it in a box for your answer. No. Now proceed to letter D, which is the average power. When we speak of the average power, we are getting the multiplication of the voltage and the current. But since this is a pure inductor, it means that the phase difference between the voltage and the current is 90 degree. So therefore, we can create a power which is on the half cycle equal to the other half cycle, the positive and the negative. So, but since the phase difference, value of is 90 degree, we can right away conclude that the average power is equal to 0 watts. Okay, so that's it. This will be your answer. So that is for letter D. And for letter E, okay, so we are tasked to get the power when T, it has a value for the time 1 over 200 seconds, 1 over 100 seconds. For T, which is 1 over 200 seconds. So what will be the value of the power? So we are to use the maximum, the equation of the power wave. That's it. So you have here P at this instance. So you have so negative 1201.9 sine 314.16. So instead of writing just T, you substitute the value 1 over 200. Okay, so that's it. So you just have to get the value of this one. So sine, that is 314.16 divided by 200. Okay, that is the value of sine multiplied by a negative 1201.9. Okay, so it will give us 32.93 watts. Okay, 93 watts. Okay, so we take the positive value of wattage, and for T, if it is equal to 1 over 100 seconds, again we use the same formula. You just substitute. It's just a matter of substitution. Sine 314.16 times 1 over 100. Okay, so you have 314.16 divided by 100. Sine of this, okay, times 1201.9. So we have here 65.86 watts. So we take also the positive value. And for the value for the seconds, which is 1/80. The same thing, so 1201.9 sine 314.16 1/80. Okay, so again 314.16 divided by 80 equals sine of this one, okay, multiplied by 1201.9, that is 82.31 watts. So those are the values. Now for letter F, we are to draw the voltage, current, and power wave. So this will also explain to us letter D. So this is our XY plane, and this is 0 degree, this is 90, this is 180, 270, this is 360 degree, okay, plus 90 of 360, we have 0, 90, 15, okay, carry 1, this is 450 degree, okay. If our reference is the voltage wave is here, it will be like this one, okay. Okay, so this will be the voltage wave form V. But since this is a pure inductor, so it lags the voltage, the current lags the voltage by 90 degrees. So the current will start here as the voltage hit the wave here at this point in time, at the maximum point. So the current will start to generate the waveform. Here is the waveform for the current. Okay, so therefore the voltage is the multiplication of your the power is the multiplication of your voltage and the current. So when you multiply the voltage at this point, which is 0 value, times the current, will give us a 0 value of the power. So your power will start here, okay, and your current is actually negative on this area from 0 to 90. So negative current times the positive voltage will give us a negative value of power. So the power from 0 to 90 will be here, okay, it will be here. I think that's better to, okay, that will be the value. And from 90 to 180, the power, the voltage and the current are all positive, so it will just be here, okay. And then when it hit 180, it will be having a negative value because V is the voltage is negative and the current is positive. So from 180 to 270, it will be a negative value, and from 270 to 360, since the voltage and the current are of the same sign, which is negative and negative, so negative is positive, so the power here will be positive, okay. So this is the power wave. You will notice that the average is 0. Okay, so this is all about the letter F requirement for this problem. So again, thank you so much for watching. To God be the glory.